In this video lesson, we're looking at circular arc length. Okay, circular arc length, it is literally the length of the arc of a portion of a circle. The arc is just part of the total circumference of a circle. And this length is measured as a linear distance, which means your final answer must have units that represent a linear distance, like inches, feet, miles, yards, meters, etc. All right, let's look at visually what we're looking to find. There's our angle, and right here is what's considered the intercepted arc. And this is the portion we're trying to find, how long this arc is. Different angle, there's the intercepted arc. And a much larger angle here, again, the intercepted arc. So again, we're going to discover how to determine the length of this yellow arc. So here's an illustration. We have a circle drawn on the Cartesian plane. We have its radius right here, and there's the angle. Notice the arc length in yellow, the letter we use to identify arc length is S. S is the letter used to determine arc length. So in this case, if theta, the angle, was exactly 1 radian, and to remind you, the radian is the opening made by taking the length of the radius and wrapping it around the circle. Once you hit 1 radius, the opening made is exactly 1 radian. So if the angle we have is exactly 1 radian and the radius is 5 inches in this case, then one can conclude the arc length is exactly 5 inches. The distance from here to here is the exact same as the radius. If the radius was 7 meters, then the arc length, 7 meters. And if the radius was 13.2 yards, the arc length, 13.2 yards. But now in this case, our theta here, the opening is exactly 2 radians. Again, from here to here, this would be 1 radius, this would be a second radius, making the angle 2 radians. So, if the radius was 5 inches, therefore the arc length would be 10 inches, because from here to here is 1 radius, 5 inches, and from here to here, a second radius, 10 inches. If the radius was 7 meters, then the arc length is double that. And again, the reason why it's double this is because the angle is 2 radians. And if the radius was 13.2 yards, then the arc length would be double it because the angle is 2 radians. So we see a direct correlation between how big the angle is in radians and how long the arc is. Last one. Let's say here now theta is actually pi radians. Because if you recall, all the way around is exactly 2 pi radians. So therefore, halfway around is pi radians. So we'll follow the same pattern. If the radius was 5 inches, here it was 10 inches because 5 inches for the radius times 2 radians. So we'll do the same thing here. 5 inches for the radius times the number of radians. And here just happens to be pi. So the arc length is 5 pi. If the radius was 7 meters, 7 times the radians, 7 pi meters. And that's what's critical, is to remember to put the units. Last one, if the radius was 13.2 yards, because the radians, the angle, was pi, simply multiply by pi, 13.2 pi yards. So we'll look at a couple, one scenario. So what we have is in review. We've got our circle on the Cartesian plane. Right here, this angle made here is the radius. So we have this pi piece, or this sector of the circle. It is formed by this angle, and that angle is formed by taking the radius here and wrapping it along the circle, creating the arc length. So this arc length is actually found by simply multiplying these two values together. So this says if theta is a central angle, again, a central angle is an angle whose vertex is at the center of a circle. If theta is a central angle in a circle of radius r, and if, this is the key, if theta is measured in radians, then the length of the intercepted arc is simply s, arc length, is equal to radius times theta. But again, theta is in radians. So if I simplify this, it simply says that to find the arc length, I simply multiply the radius times radians. So that will be the formula we use. Radius times radians. But it poses the question, what if the angle was measured in degrees? Well, if it was, you simply convert the degrees to radians. Meaning, if you recall, here's our degrees. To convert to radians, we simply multiply by pi over 180. Or simply take the degrees and divide by 180 and put pi in your final answer. So if we put all of this together, so if we substitute this here back for theta in this formula, we get a whole new formula for when theta is in degrees. Now, I color coordinated it so you can see that this is essentially, I'm taking my radius times the theta, so it's the exact same thing. But this is showing that all I'm doing is dividing by 180 and putting pi in my answer. So if I do a couple examples. So the first one has theta in radians, the second has theta in degrees. So if it's in radians, we're simply just going to multiply the radius times radians. Radius times radians. So the radius was 13, radians 2 pi over 3. So we simply multiply these two values together, 13 times 2/3. I'm going to show it in the calculator just to illustrate. So 13 times, I can do 2 over 3 if I wanted. Calculator says 26 over 3. If I did 13 times 2 divided by 3, it'll first give me a decimal, but I can tell the calculator to convert it to a fraction, 26 over 3. So the calculator helped us come up with the numbers. We just got to put the pi in our answer. 26 pi over 3 inches. So I have both the pi and my units. So now the next one, it's with degrees. So what we first need to do is convert the degrees to radians. Here's the formula, but I'm going to work through it in a more logical sense. First, I'm saying I'm going to convert the degrees to radians, and then I'll have radians times the radius. So if I went to the calculator, we're going to go here, we'll close these two. So I'm simply going to take my 150 divided by 180. That way, I can at least see that this number here, which looks kind of funny, let's go and convert it to a fraction. This is our radians, 5 pi over 6. So now that I have radians, simply multiply it by the radius, 12. So we get 10. So the final answer will be 10 pi centimeters. So this is just showing everything substituting. The theta is the 150, that's my angle. The 12 is the radius. It shows that I'm going to divide the 150 into 180 and then multiply by 12. There's our 10 pi centimeters. So I got a couple more examples just to reiterate. All right, find the length of the arc. Here, because of the pi, we know we're in radians. So we're simply going to multiply. So we're just going to simply do, what is that, the 4/3? 4 over 3 times 6. And it's a, oops, let's clear that. 4 over 3, let's move it over. That's radians times the radius, 8. So therefore, my answer is going to be 8 pi radians. 8 pi meters. 8 pi meters, sorry. So again, because it was in radians, simply multiply radius times radians. Next one, it's because it's in degrees. We're first going to convert it to radians and then multiply by the radius. So we're going to do one long keystroke. We'll do the 135. We'll divide it by 180, because that will give me my degrees, my radians, and multiply that by the radius. 9.75 converted, 39/4. If I did it in multiple steps, the 135 divided by the 180. So there's my radians. I'm making it a fraction. There's my radians. Now multiply by the radius times 13. Bet. 39/4. So this is showing the exact formula. Substitute everything in. There's the 13 for the radius. There's the 135 for the angle. There's my 39 pi/4. Two more examples. Now this one is without the diagram because we really don't need the diagram. We just need to know the values. The fact that my angle is in radians, we're going to do radians times radius. So what's that? 17. We'll close all these out. Simply 17 times 5, 6. Radius times radians times 5/6. Done. And when I type it in as a fraction, it gives me the fractional answer. So 85 pi/6 will ultimately be our answer. 17 times the 5 pi/6, there's the 85 pi/6. Meters, don't forget the units. Last one, here we have degrees. So we'll first convert the degrees to radians by dividing by 180. So there's our 150 divided by 180. That's our radians. There it is, 5 pi/6. Now we just need to multiply by the radius times 14. Bam, 35/3. Could have done it one long keystroke. 150 divided by 180. Now times the 14. We'll get the exact same thing, 35/3. So, again, there's the formula. The radius and our angle will be substituted. There's the radius 14. There's the angle 150. There's our 35 pi/3 yards. So hopefully this helps you understand how to find arc length. As simple as radius times radians. If it's not in radians, if it's in degrees, simply convert it by dividing by 180 first.